Welcome, everyone. We are just, while we're waiting for everyone to arrive and get settled, we just wanted you to have a chance to see some of the students who have participated in this year's fair, and look at some of the projects that they've done. In addition, we just wanted to let you know that this is being recorded so that people can watch later.
Good afternoon, everyone. On behalf of the Jandon Center for Community Engagement, welcome to the Smith College Western Massachusetts High School Science and Engineering Fair. I'm Deborah Day, STEAM Outreach Coordinator and the chair of the Regional Science Fair. I'd like to begin by thanking the students, parents, educators, and mentors who showed up not only today, but over the course of the last academic year to support the continued learning and advancement of science and engineering during this unprecedented year. I'd like to give a special shout out to various groups of people who have spent countless hours behind the scenes in order to make the Regional Fair award ceremony possible. Our devoted Western Mass Science and Engineering Fair committee members who meet year-round to plan and organize the fair, including logistics, scientific review committee, technical support, and beyond. I'd also like to thank the Massachusetts Science and Engineering Fair support team, whereby members regularly attend our regional meeting, host high school and middle school director meetings, and give continuous support to our fair. The Smith College support team and sponsors include Dean Bashaki Taylor, and from the Jandon Center for Community Engagement, Dennis Candy, Clark Science Center, Professor Kevin Shea, the Smith Bookstore, Smith College Bookstore. Thank you for all your support. We also like to give a shout out to all those educators from 7 different schools represented around Western Mass. Our judges this year were 37 in number, and each judge had 3 to 4 projects to judge, and each project was scored 5 times and averaged. Thank you, judges, for your time. Our students were able to present either proposal projects or completed scientific projects. Thank you, students, for taking the time to create your presentations and share them with us today. Congratulations for being here. Hello, everyone, and welcome. I'd like to reintroduce myself as we segue over to our live streaming portion of our virtual awards ceremony. I'm Deborah Day, the chairperson for the Western Mass Science and Engineering Fair, and I would be remiss not to mention the beautiful work that's been done by my colleagues, Maddie Del Vicario and Becca Jacobson, for every detail of this Science Fair Awards ceremony. And they're working now behind the scenes with me, and I'd also like to thank Nancy Ziegler for her logistical organization and planning for our event itinerary. Our STEAM team is made up of Smith College students, Megan, Vivian, Elizabeth, Erica, and Emma, who have contributed enormous energy and time over the last several months supporting and enhancing this science fair experience. I'd also like to continue with our congratulations to all of this year's high school science and engineering fair participants for being here and choosing to pursue your interest and love of STEM research and education. We hope that you'll continue your curious investigations throughout your lifetime and inspire others to do the same. We'd like to note that although we found all of your projects fascinating, those award winners today will receive a ribbon or medal and monetary awards in the amounts of $75 for bronze, $150 for silver, and $300 for gold. Before we announce this year's winners, we have a very special opportunity to hear from a team of creative engineers centered right here at Smith College. Better known as Smith Bent, this team came into existence approximately 1 year ago as our world struggled to overcome obstacles related to the pandemic. Led by Smith College professor Susanna Howe, this team rose to the occasion. We're so honored to have you here with us today, Susanna and your fellow Smith Bent teammates. And we want to know more about how you collectively accomplished this. So without further ado, I'd like to introduce Professor Susanna Howe, who will then introduce her team, discuss their amazing success, and follow up with a short question and answer session to follow. Students, we would love to see questions from you populate our chat. And without further ado, Susanna.
Hi there, I'm Susanna Howe. I teach here in the engineering program at Smith College, and I was on sabbatical last year when the pandemic hit and was really wanting to find ways to get connected and contribute to COVID amelioration efforts. And I found out about a competition to design a ventilator. And I reached out to a pool of engineering alums, many of whom I had taught over the years. And very quickly, we formed a 30-person team that entered this competition. And to be honest, we had no idea what we were getting ourselves into. We were really excited about the opportunity to work together for a common cause and to put our engineering and science talents to work in a new area. And then we ended up winning the competition. And it was an absolute whirlwind for about 10 weeks as we developed the idea for a ventilator from scratch and then made it onto the second round and actually were chosen to be able to build our ventilator and demonstrate it, and then won the whole competition. And that project is even continuing now with some additional work by some Smith students this year. So it's a really fun opportunity to work on engineering in a team for a really important cause. And we're doing better in terms of ventilators in the US, but there are many places around the world that still have severe shortages in medical equipment like this. And our goal was to design something that could be manufactured and fabricated far less expensively than a typical commercial ventilator, and yet would still have the same kind of functionality necessary to help keep patients alive. So I'm here to happy to answer questions. We have a short video that we will show you that talks about our team and some of the experiences that we had. And I'm also joined by my co-leader, Astrid Landau, who can introduce herself.
Hi everyone. So I guess I'll just chat about how I ended up on this team and kind of what I did. So I think like possibly most of you, I was watching the pandemic unfold on TV and just wondering what can I do? I'm not a doctor, I'm not a nurse, I'm not a frontline worker. How can I contribute? And I got that email from Susanna saying, hey, I'm looking for a team to design a ventilator. Of course, I had never done a ventilator design before. In fact, I haven't necessarily worked in the medical field at all, but I said, maybe this is what I can do. So I put my hand up. I am a project manager, and I was like, maybe I could help manage this project. And thankfully, I was able to. So Susanna and I worked together to build basically a system that took us through a whirlwind 10 weeks of work that, of course, as she mentioned, kind of culminated in us winning the competition. It was great fun for me to kind of reconnect with all these alumni from Smith, but it was also really, really heartwarming to see that even with like a mishmash of skills that aren't necessarily exactly what's needed to build a ventilator, that we were able to put something together that had substantial kind of standing in the community, so much so that our work is still being worked on in many different countries all over the world, and of course at Smith College as well. So it's been a great experience.
Would you like me to start the video? Okay. Give me 1 second.
For me, this competition has never been about winning or losing. It's been about coming together, sharing our efforts, learning from each other, and contributing something to a bigger cause. The timeline was absurdly short. To try to go from 0 to 60 in less than 2 months. In 2 months, we went from knowing nothing about ventilators to now having a functional prototype. That's crazy in my mind.
I want to be able to make an impact and contribute to something bigger. As an engineer, one of my main goals is really to use technologies in a way that helps benefit people and society in some way.
I would always work with Smith Engineering alums.
Notice we're getting 2 waveforms, a flow and a pressure. And we've got our balloon breathing. And we've got our PEEP valve functioning. That's the noise. All our solenoid valves are working. And we've got screen. Patient data updating. We've got waveforms moving.
There was one moment that Susanna, like there was something wrong with the wire connection, and I was just telling Susanna to use a multimeter to troubleshoot, like measuring connectivities and measuring voltages where it's supposed to be like high or low. And then she's like holding an iPad and then like putting a multimeter on the desktop and holding the camera so that I can see the zoom, but actually like put on her knee for an iPad and then using 2 hands to poke the 2 like leads that we want to measure.
At least with this screen, I was sort of working like in between electronics and UI and code. There's like a lot of integration like all throughout, right? You never know where the problem is. On the actual prototype and troubleshooting there, that was yet a different aspect because there's all these other moving parts as well.
We really took it from a conceptual place where all we had to go on was like physical properties and like flow equations and things like that. And we really took all these physical properties and all of the knowledge that we had researched about the medical community and brought it all the way through to a physical product, a prototype.
The Smith vent design will allow gentle air delivery to the patient, proning if necessary, and liberation from the ventilator with its pressure support mode. Our manufacturing strategy uses mainly readily available off-the-shelf components, reducing complex machining and supporting compatibility with current medical equipment.
In some places, it made sense to do 3D printed fittings to connect from medical fittings to MPT pipe threads.
The enclosure design is user-friendly and easy to clean. The sophisticated control system ensures flexible inputs, patient data monitoring, and various levels of alarms.
Our team's main goal is to create a user interface that's easy to use and hard to make mistakes for exhausted healthcare professionals. This top portion of the screen includes the waveforms of flow versus time, pressure versus time, the patient data, as well as icons for the alarm, battery, power, and date and time. In the bottom half of the screen, there are interactive buttons where the user is able to change parameter values. And then on the right-hand side of the screen, there are different tabs that the user can navigate to.
Seeing the whole system breathe on Zoom, when it turned on the power and starts breathing, and this little toilet paper starts flicking up and down.
We decided to make a ventilator, and now we have a thing that blows up a balloon, and that's pretty awesome.
Wow! Look at that! It's breathing!
All right, Smith Vent, thank you for this wonderful video. And now for our participants, if you want to go ahead and start putting any questions for our panelists in the chat, that way we can sort of hear about, specific questions and thoughts that you're having. So just go ahead and write them in the chat. You should see the chat feature on that bottom bar for those of you who are new to Zoom, and just make sure that the setting is sent to panelists and attendees so that we can all see the questions that are coming up.
And while we're waiting for questions to come in, I'll just mention, this was a 10-week experience. There were sort of two phases of the competition. The first one was entirely conceptual, and so we just had a plan of what we wanted to do, and we had some CAD models, some three-dimensional computer models, but we didn't have anything physically built. And then the second half of the competition was building and testing, and that's what you saw largely in the video there. And then the competition ended on July 1st, and we were announced as the winners. But we never came into this competition intending to commercialize and manufacture these devices. The design itself has a long way to go in terms of what would be needed to make sure that it's robust enough to be used on patients. And that was why we felt really strongly that we would be part of this open source movement, making our design available online, and so other people could then download parts of it or the whole thing and revise it and make it better and use it in different parts of the world. So in fact, I'll answer that with the question, has anyone downloaded it and used it in the real world? So yes, so we've actually been in touch with several different groups. There's one in Brazil, there's one in India, and there's at least one more in the US that have downloaded it, that have been asking us questions about it. And we've shared information about what we've done, and they've shared some information about how they're making changes and trying to use it, have it work in their part of the world. But it's important to keep in mind this is a sort of device as a life-saving device requires quite a lot of testing and quite a lot of refinement and also clearance of various regulatory standards. And so this, if it is to be used for patients, it won't be used at least for another year, 2 years, 3 years, something like that, until all of that testing has been done. But I feel like we launched something that has gotten started and is a really good foundation for other people to build on.
Yeah, I think I'll just grab the question on the main challenges coordinating everyone in different locations. We had, as you know, about 30 different members. They were all across the US. In fact, I'm in Canada. We had another member in Germany. So we were working different time zones, people with different expertise, not just time zones, but people with different availability, people who would be able to come in after work or maybe grab an hour of work during lunch. So what we did is we created a spreadsheet, nothing fancy, but absolutely necessary. So that was basically a spot where when you had time available, you can drop into the spreadsheet, see kind of what activities were open for work, and then jump into those activities, update the percentage progress, and then close the activity when you were done. So that was basically the war room, the place that you would come to figure out what was going on with the project at any given time. And that's kind of how we did coordination.
I'll take the question here about some challenges with the coding aspect of the ventilator. So the whole system is run through an Arduino Mega, and so we are working with the development environment for Arduino, and we originally had different people coding different components. We ended up putting our code together on GitHub, which is a shared repository for code, which will allow our different members in different places to be able to work on code and update the code and work collaboratively, but in different locations. I would say the biggest challenge we had actually with the coding aspect was working with the screen, the user interface, partly because some of the files that came with the screen were not quite right, and so we needed to find some updates, and we found some assistance from various user groups online who gave us some sort of code patches that we could put in. And so there were just a lot of different components that we had to get working together. So there's the Arduino Mega, and then there are various valves and electromechanical components in the design, and then there's the user interface as well. And all the different parts and pieces had to work together to have the system work as one.
Yeah. I'm just looking at the question on where we encountered our biggest learning curve. Funny enough, we spent a lot of time trying to figure out what a ventilator even was. A lot of us were coming into the project with no medical background whatsoever. It was kind of funny that we just thought a ventilator was a box with a screen on it. That's kind of all we knew at the inception of this project. So we did do a lot of research. We reached out to a lot of medical professionals to kind of help us understand just like what is a ventilator and how it works. And I think at the very start, that was the biggest challenge, just to kind of wrap our head around what exactly are we trying to build? What are we trying to achieve? What does it need to do?
And we did a lot of research. We'd seen a lot of other DIY or do-it-yourself ventilators, many of which looked good on the surface, but really would not have been robust enough to sustain a patient for the length of time that COVID patients tended to be on ventilators. And it quickly became clear to us in doing this research that we needed to design something that would last longer and that was more robust than many of those ventilators were. And so I think what we came into the competition thinking we might be designing ended up being, we ended up designing something that was much more complex than what we had realized when we got into it. And I think the learning curve of having to learn all the different parts and pieces and how it fits together. But we had a very engaged and committed and efficient team. And we built a very strong culture of respect and trust and an ability to learn together. And I think that was a really powerful thing for us, that we could lean on each other to learn things, and we could also lean on our networks outside of our team and bring in experts who had different expertise in particular areas and leverage all that information as one big unit and take that forward. So it wasn't that any single person in our group came in with knowing all the answers. In fact, many of us knew some pieces, but none of us knew enough to do the whole thing ourselves. And it really needed the whole team. And then we all needed to learn as well on top of that.
Awesome. I think
So
we have,
it was
yeah,
really strange.
we have time for one more question. And this is a really great kind of wrapping up question. So what is the biggest takeaway from this project for each of you?
All right, I'll say for me, I think the biggest takeaway was that with a team of people, you can do almost anything. And I think if I had realized, if someone had shown me at the beginning of the competition where your team is going to get to the point where it will have this design, I would never have believed them. And honestly, I think if I'd known how complicated this was, I'm not sure I would have gotten into this in the first place. And so I'm really glad that I didn't know, because I think that fear would have kept me from doing it. And I'm so glad that we just dove in to do it. And also that we had each other to do it with. And so I think that the biggest takeaway is that you can do so much if you put your mind to it. And if you have the right people around you who are willing to work and willing to learn, even if you don't know it all in the beginning, you will learn it together as you go forward. That was a really powerful lesson.
Yeah, I would say something similar. When I looked at the challenge, that email I got from Susanna, I'm thinking, I can't do this. Like, I don't know anything about ventilators. Like, what am I going to contribute? How does my skill set fit in? I'm not basically 100% qualified for this. I feel like I'm just 20% qualified. What do I do? And I think the biggest takeaway for me is like not to let that fear get in the way of me doing something. It was a bunch of us with 20% skill level in what we're doing. And somehow those little 20% everywhere led us to a winning design. So I think the biggest thing is not to necessarily down yourself. You don't need to know everything. You're never gonna know everything, but don't let that stop you from still contributing in whatever way you can.
This is just absolutely incredible. And I think what you said, Astrid, just this idea of that, like, you can build a group with like folks who know 20%, but each of you know a different 20%, and together that makes like a completed group. And so that's just like so powerful to think about, that you don't need to go, you know, similar to Susanna, you don't need to go in knowing everything. You can go in knowing very little, and just really having a supportive network and a supportive team. This is just absolutely incredible. Thank you so much. And thank you for taking your time today. This is just absolutely what an incredible and inspiring thing. So yes, thank you so much.
Thank you for having us.
Yeah, thank you very much. And congratulations to all the science fair participants. Great work.
Thank you. We really appreciate you being here. Thank you.
And so now I will pass it back to Maddie, who will continue on with our pre-recorded award ceremony. And now for our winners.
My name is Maddie Del Vicario. I'm the Experiential Learning Coordinator at the Jandon Center, and I'm here to announce the top 5 project proposals. Ella Mastrioani, Westfield High School, The Connection Between Music and Our Hearts. Amir Kashu, Westfield High School, The Best Alternative. Max Kusner, Westfield High School, The Hydraulic Lift. Melody Lachaw, Westfield High School, Creating an Eco-Friendly Disposable Face Mask. Elena Zhao, Northfield Mount Herman, an interactive artificial intelligence design framework for Nacre-like structure optimized for crack resistance. Congratulations to our top 5 proposal projects.
Thank you to A to Z Science and Learning store for their support of the proposal projects. Each proposal project winner in the top 5 group will receive a $25 gift card to use at the online or in-person store in Northampton. Thank you, A to Z, for being a sponsor of our fair.
I'm now happy to announce the honorable mentions for this year's High School Science and Engineering Fair. Team from Westfield Technical Academy, James Coach and Ava Montavani, biodegradable face mask breathers. Team from Westfield High School, James Krupinski and Caitlin Price. Project, best type of turf grass to grow for droughts. Ariana Czeschini, Westfield High School, diet plans made easy. Congratulations to those who received an honorable mention on their completed projects.
Hi, my name is Becca Jacobson. I am the Community Engagement Organizer at the Jandon Center, and I will be announcing our bronze medalist winners. Lauren Newbill, Westfield High School. How do military grade glow sticks compare to standard glow sticks in brightness and longevity? Martin Winsey Gong, Deerfield Academy, efficient page turn method based on gaze tracking. Brian Lee, Northfield Mount Herman School, deep learning of mitosis from cancer tissue images using convolutional neural networks. Hareen Kim, Northfield Mount Herman School, weighted top K group skyline query. Sarah Moriarty, Westfield High School, how online learning affects our eyes. Congratulations to the Bronze Award winners.
I'm happy to announce our silver medalists. Alex Sengbin Choi, Northfield Mount Herman School. Increase in COVID-19 infection caused by changes to ACE2 and TMPRSS2 expression in aging cells and preventative effect of vitamin C. Kierden Kearns, Ralph C. Mahar Regional High School. Preliminary investigation of the facial integument of Allosauridia and the evolution of theropod facial armor. Suvin Sundararajan, Westfield High, photocurable cross-linked resin for SLA and DLP 3D printing. Winston Wu, Northfield Mount Herman School, Machine Learning Classification of Stars, Galaxies, and Quasars. Team from Westfield High School, Abigail Menzel and Emma Petzold, creating bioplastics using biodegradable polymers. And now we're thrilled to announce our 2 gold medal winners. Ayo Guy, Deerfield Academy, improving the aerodynamic efficiency and decreasing the drag coefficient of an F1 in schools race car based on further evaluation of aerodynamic principles and designs. Leah Jiaolu Pian, Northfield Mount Herman School, Density Functional Theory Calculation of Electronic Structure of FENC, FEOC, FEPC, FESC, Single Atom Catalyst Systems. Congratulations to our Gold Award winners. And congratulations, everyone.
All participants in our high school fair will be eligible to advance to the state fair, the Massachusetts Science and Engineering Fair. We will issue a follow-up email next week containing a customized digital swag bag with a personalized certificate of participation, digital badges, and vouchers from A to Z Science and Learning Store and Smith College Bookstore. Winners will also be given additional information regarding paperwork submission for cash prizes, and the top 2 winners will have the opportunity to advance to the International Science and Engineering Fair. Prize medallions and ribbons will be mailed to award winners via U.S. Post in the next few weeks. Once again, we'd like to thank you for all the work that you've put into this year's Western Mass Science and Engineering Fair, and thank you for coming to our awards ceremony.
Congratulations, everyone. Oh, you're muted, Deborah.
Ooh, there we go. Thank you, everyone, for coming. It's nice to see that we had a good amount of participants in this, and we will record it and make it available for you and your friends if they couldn't make it. So thanks so much, team. You're always there to be so supportive, and things will get out next week for sure, if not sooner. But great job. We want you to continue to do your research, and we're very proud of your work. Thank you for coming.
Bye, everyone. Have a great rest of your weekend.